So this is Pre-Calculus, Unit 3, Review Problem number 19. And this is very similar to a problem that we did earlier in Unit 3. And it's asking us to analyze a rectangle that has a base that's on the x-axis and two upper corners that lie on a parabola, y equals 20 minus x squared. Now they're asking us to draw the scenario on this coordinate plane, and they've given us a very generic, there's no scale or anything on this. So we're going to just make it into kind of a sketch. We're not going to officially graph it in too much detail in order to be able to answer the remaining problems that we see here. So let's get that started. All right, so I went ahead and put some of my equation, my function into a graphing calculator, and I, being the obsessive that I am, decided to calculate the zeros and the maximum officially on the calculator in order to make sure that I just had some labels on here and I got some perspective as to what the rectangle side lengths really could possibly be. So because our extended side over here stops at 4.472 approximately, we know that we're never going to have a rectangle with a side length x of more than 4.472. So a side length of 5 would be impossible. So in my head, that just helps me kind of put some perspective to what kind of rectangle size I'm actually looking at. Now, they're not asking us for that in this case. They're asking us simply to label our base and height of the rectangle in terms of x. So let's build a triangle and start to label. Excuse me, we're building a rectangle. Alrighty, so let's take a look at our rectangle. So if you look at the green rectangle that's been provided here, the distance in this direction is x. And then the distance in this direction is, because it's distance, it must be positive, so it is also x units. And of course, the output of this function is the value 20 minus x. So this ordered pair right here has the ordered pair x comma 20 minus x. So because we're expressing the area in problem C, we need to be able to use these two quantities in order to express basically base times height of our triangle. So let's get that through. So I believe we have established that the base of our rectangle here is 2x. We have x plus x. The height of our rectangle then is 20 minus x squared, which is actually given by our function. Okay, so let's actually write this. A equals the area of, excuse me, I should be more appropriate there. A of x, because we're putting this in terms of x, equals base, which is 2x, times the height, which is 20 minus x squared. Now, we're going to simplify that, all right? 2x times 20 is 40x, and 2x times negative x squared is negative 2x cubed. All right, so the area of this rectangle is, in terms of x, is 40x minus 2x third. Now, the next question asks us, what is the largest possible area? And we're, of course, going to use our trusty graphing calculator in order to determine that. So in order to figure out the largest possible area of our rectangle, we do need to take that actual function and put it into the calculator, okay? It is a cubic function. And so I put it into the calculator. This window took me a couple of tries. And even though way back when in this problem, I analyzed that my x's can't really go beyond positive 5 and negative 5, I was inputting these giant numbers for x, okay? So do use logic. We know that our x's minimum isn't going to go beyond negative 5 for sure, and our y values really can't, or excuse me, our x maximum isn't going to go beyond 7. Okay, so that even with the area changing, we still are only using a rectangle that is going to have sides of a maximum of 5, so our x value can be 5. Now my y values, I played around with that. I knew I wasn't going to have any negative area, so my y minimum, I just put it -3. And then my y maximum, I'm like, okay, I don't know how far my area is going to be here. So I just put in a 100. Now that I probably could have made that a little bit smaller, but you know, at least I can see part of that cubic function is going to go down and kind of come up like that. I don't need to be concerned with the negative portions because it's not a part of my logical domain. The relative domain is only positive numbers in this case. So what we really need to do is find, because this function is giving us the area of our rectangle, The question is asking us for the maximum area, which will be found right here on our function. So let's have our calculator calculate the maximum for us. So in calculating the maximum, we can see here on our trusty little calculator, we have an x value of 2.581 and a y value of 68.853. And it's our job to be able to interpret this. The largest possible area, now remember the output of the function gives us the area. So the largest possible, the maximum area will be 68.853. And do we have units here? Nope, no units. We're just going to say units squared. Okay. And that is because that is the maximum of our function. It actually is giving us the area. That's what this function actually does. Now our last question here is at what x value should the rectangle be drawn for that largest area? Well, that also is given to us in this maximum. So that would be a side length or an x value here. If we would plot that triangle at 2.582 units to the left and 2.582 units to the right. Okay, so each of these would be at 2.52 here and negative 2.52 here, and that would give us the rectangle that has the area of 68.853 units. 853 units. Okay, so this problem is an excellent problem with so many aspects of what we have been learning. The interpretation of a function, using the graphing calculator, using a quadratic function, using the window, minimums and maximums and zeros, and just a lot of that kind of stuff. So please study this well and be prepared. Okay, thank you so much.